All right, guys, we're going to go ahead and take a look at the video for lesson 7.6 and our focus here and what you're going to be doing. We're going to be doing looking at some track and field world record times and doing some things with those and looking at some different type problems and thinking you could have to solve them. Okay, so and number one, as of 2014, the women's world record for the 100-meter dash is 10.49 seconds. So about how many meters per second was the record holder running? Okay, so I'm looking for meters per second. How far did they run every second? So again, that's that unit rate. We want to get it down to 1 second. Okay, and that's how we want to know how far they were going, every 1 second. And obviously it's going to be pretty fast. This is a world record. So a couple different ways to look at this here. If I'm doing, let's just set up a little ratio here. We're going meters compared to seconds. Okay, so meters to seconds. And what I know right now is they go 100 meters, takes them 10.49 seconds. 100 meters takes 10.49 seconds. So I know to get it to meters per second, I want to get this down to 1, unit rate. So I'm going to divide by 10.49 to get me down to 1 second. So I must also divide this, divide by 10.49. I'll just write it in small there. And if you take 100 divided by 10.49, you'll have to round it here, it's about 9.53 meters per every 1 second. Okay, 9.53 meters. Okay, nice. So that would be my answer. How many meters per second? I'll just label it like that. Meters per, you can use a slash for per. 9.53 meters per second. So you think about that, you know how long a meter stick is. They're running 9.5 of those approximately every second. I mean, really fast, covering a lot of distance here. So that's one way to think about it. Some people, you could set up a proportion if you wanted to. Okay, so like just thinking about it a little different way, meters over seconds. If you're thinking about it this in a proportion, you could say, well, 100 meters takes 10.49 seconds. And I want to know, so I know the, sorry guys, I'll flip that back on there. Okay, so what I want to know here, I've got 100 meters, takes 10.49 seconds, and I know I want to get this down to 1 second, so I can just call this x here if I'm doing my algebra. Getting a little bit tough to see, let me move it over here. So I've got meters per second, so I've got 100 meters takes 10.49 seconds, and I know I want to get it down to 1 second. All right, so the time's on the bottom here, so I want to know how many meters this is. I'll just call it x. All right, so 100 meters takes 10.49 seconds. Okay, so how many meters can I get in 1 second? And you guys know if I just divide by 10.49 here, that goes down to 1, so I could divide that by 10.49. It ends up the same thing I did over here. Well, remember we talked about that cross multiplying when you're solving proportions, so sometimes we'll make these arrows. Okay, and we'll solve it with algebra. 10.49 times x is just 10.49x equals, and that has to equal 100 times 1, which is 100. So it just turns into an algebra problem there. So 10.49 times x, to undo that, I divide by 10.49. That undoes it and just leaves me with x, so I must divide this by 10.49. And 100 divided by 10.49 gives me 9.53. Okay, so again, it ends up the same thinking as that. Some of you like to set up these proportions, but different ways to think about them there a little bit. Okay, all right, number two, about how long would it take to run 400 meters now, that if a runner maintained that same rate as the record holder in problem number one. And you're probably thinking, no, you can't run 400 meters, probably the same pace that you're going to run 100. But if you did, it would be really fast. So we know a 100-meter dash takes 10.49 seconds. So we could say 10.49 seconds. Okay, we know that is for 100. And if I keep that same pace, how many times do I have to do that to get to 400? I would just do that 4 times in a row to get to 400. So 10.49 times 4. If you take 10.49 times 4, you'll get 41.96 seconds, okay, to run 400 meters if they kept that rate. Okay. And again, that'd be really, really fast. When you scroll down later on your next slide, when you're doing some work, you'll see the 400 dash isn't nearly that fast. It actually talks about it right here. We'll get to that in a second. But there's just one way to think about it there. You're just doing this 100-meter dash time 4 times in a row to get to 400. Again, that would be very, very fast there. Okay, you could also, another way to do it would be to take your 400 meters and divide into groups of 9.53. How many 9.53s? Because that's the meters you're going per second. And then how many of those do you have to do to get to 400? Okay, you could set it up as a proportion too, or as algebra, I can solve it with algebra, but here, the thinking again, if you're just thinking dividing is how many of these does it take to get to there? Because every 9.53, they're going that every second. So how many seconds to get to 400? You do the same thing. I think it comes up 41.97 something. Remember 9.53 was rounded, so it's a little different. But again, you get about 41.97 seconds. Again, same thing there if you kept that same rate. So a couple of different ways to think about it there. Okay. The world record time for the women's 400 meter dash is 47.6 seconds. How does this time compare to your answer in problem 2? And we know for that it is a lot slower, about 6 seconds slower. Okay, so we could say it is about 6 seconds slower. And again, we know the reasoning behind that is you just can't sprint for 400 meters like you would for 100. You get too tired and your pace slows down. So again, that time would not be reasonable for a 400 time. And the world record still really, really fast here, 47.6 seconds. So you'll be doing that kind of thinking today, using a lot of unit rate. I'm dealing with some world record times in things in your future slides here. So do your best on your practice slides today.